Okay, let's have a look at this design problem. Now we've been given the R1 value, it's 1K, so I've put that in over here. We're told basically we want the fan to actually turn on when the input voltage over here is equal to 5 volts, and then we want to turn the fan off when the input voltage has actually dropped to 4 volts. And our task here is really to see if we can find the R2 resistance and also see if we can find the reference voltage. All right, a couple of things to note. First of all, we can say V in H. Well, what is that? Of course, that's equal to the 5 volts, isn't it? And of course, the V in L, which is our turn off voltage, that is equal to 4 volts. All right, we also know this voltage here, V1. All right, and as we've done before, we can say that V1 is really equal to what? It's equal to R2 over R1 plus R2 times the input voltage plus R1 over R1 plus R2 times the output voltage over here. Okay? All right, what else? Well, look, let's just show the graph here of V out. And this is versus V in. All right, we're going to start here, minus 15. And if we look at what happens, we'll switch to a plus 15 over here. When what? When the input has reached V in H. V in H is, of course, 5 volts. Then, if we reduce V in, we're going to switch back again when V in has reached V in L, which is 4 volts. We'll then go from a plus 15 to a minus 15, which indeed turns off the fan. Okay, so we can say what the hysteresis is, and we can say V hysteresis is really equal to what? It's equal to basically the 5 minus the 4, so it's really 1 volt. And that is equal to, if you go back and look at our previous video here, that is equal to 2 times R1 over R2 times 15. Of course, 15 is our power supply voltage. Okay, so these two relations here and here are going to be important for us in terms of finding that resistor R2 and also finding that reference voltage. All right, let's use this relationship here. We know what R1 is. That's given. R1 is equal to 1K. So let's put this information into here and we'll solve for R2. So look, we can say that R2 is equal to 2 times R1 times 15. So putting this value in, we get R2 is equal to 2 times, what is that, 1K times 15. And so therefore R2 is really equal to what? 30K. So we have that value for R2. All right, so we've found this R2 value, and this R2 value, I'll just put it in here, is our 30K. All right. Now, as I said before, V1, of course, is this relationship over here, and we know that switching is going to occur when this V1 is actually equal to the reference voltage. Now, if we assume a starting point, let's say where V out is minus 15, we can actually say or look for a specific value now of V in for that switching condition. And so we can say V1 then is equal to the reference voltage at switching, which is equal to R2 over R1 plus R2. Let's go ahead and put in values. R2 is what? 30K. And R1 plus R2 is 30 plus 1K. So that's 31K. That is times V in. It's a specific value of V in, and we're going to say that it's V in H. Okay. Then we've got R1, which is what? 1K divided by R1 plus R2. R1 plus R2, which of course is our 31K, and that's times the output voltage, which we're assuming to be the minus 15. Okay, so what do we have here? Do we have everything in this equation? Well, we really do, don't we? We're going to solve for V reference here. We know what this V in H is. What is it? Well, it is 5 volts. That's part of the specification. Okay, so we can actually put all that information in and we can say V reference then is really equal to this 30K divided by 31K times the V in H, which of course is the 5 volts, minus 1K divided by 31K times 15, okay? All right, so if we were to evaluate this term over here, and I'll let you do this, but this comes out to basically 4.834, little rounding there, okay? This term over here comes out to be a minus then, and this is a 0.484. And so therefore we can say then that this V reference is simply equal to the subtraction of those two terms there, which is equal to at 4.35 volts. And so therefore we've really completed this design, the reference voltage over here being 4.35 volts. All right, so that's a design problem where we actually specify what we want as a turn on voltage for the fan and a turn off voltage for that fan.